Light moves fast. So fast, it circles Earth 7 times in a single second. So fast it could take you to the moon in less time than a heartbeat. And yet, not infinitely fast, not instant. It's not omnipresent. That matters, because the universe doesn't run on absolutes. It runs on limits. The speed of light is not just a speed. It's not even about light. It's the boundary of influence. The maximum rate at which anything, information, matter, even causality can travel. If something happens far away, the effects won't reach you immediately. There's always a delay. A pause between cause and consequence. And that pause is sacred. Without it, cause and effect would blur. Actions would arrive before intentions. Events could precede their own beginnings. The laws of physics would become a hall of mirrors, beautiful but broken. But the speed of light holds it together, not because it's fast, but because it's finite. It defines the edges of now. It's a boundary between here and too late, between knowable and forever out of reach. Every star you see tonight is a story from the past. Every moment of vision is a memory delivered just on time. Light doesn't just let us see, it lets us sequence. It turns the universe from chaos into a story. And it sets the rhythm of time itself. We tend to think of speed limits as obstacles, things we wish we could break, but this one is the reason anything makes sense. The speed of light is not just the limit of motion, it is the limit of causality. And that changes everything. There are numbers in physics that feel almost mystical. The gravitational constant, Planck's constant, the fine structure constant, strange, dimensionless, and seemingly carved into the bones of the cosmos. But one number stands apart, not because it's the most mysterious, but because it's the most definitive. 299,792,458. That's the number of meters light travels in a single second. In a vacuum, it's not an estimate. It's not even something we discover anymore. It's defined, baked into how we measure everything else. The meter itself, the unit we use to measure all distances, now pegged to this number, because that's how reliable the speed of light is. It's not just a benchmark, a pillar. But here's where the real twist begins. Despite the name, the speed of light isn't really about light. Light just happens to obey it. But the limit belongs to the fabric of space-time itself. Any massless particle, anything that carries no rest, mass will move at this exact speed. Photons do. So do gluons, at least theoretically. And gravitational waves? They also propagate at the speed of light. This isn't a law that only applies to lasers and flashlights. This is a law that shapes how information moves in the universe. It is the speed of causality. Why is this strange? Because it forces the universe to behave in unexpected ways, you might think. If I move fast enough, if I push hard enough, I can go faster. But that's not what happens, no matter how fast you're already going. No matter how much energy you pour in, you can never reach this limit. Instead, time stretches. Distances shorten. The universe itself bends to prevent you from crossing that line. It's not a wall you smash into. It's a horizon that keeps slipping farther away the faster you run. And light? Light just follows the path space-time allows. It's not trying to be special. It's just the one thing fast enough to keep up with causality. The real revelation isn't that light is fast, it's that nothing can go faster. And the universe treats that as sacred. This tells us something profound. Space-time isn't just a background where things happen as rules. It reacts to motion, it protects consistency, and at the center of that protection is this one unbreakable rule. Information cannot travel faster than light, because if it could, the future could affect the past. Cause could arrive after effect, and everything. Reality, memory, meaning would come undone. We don't often think about it, but when we say, this happened because of that, we're invoking the speed of light, not just as a speed, but as a boundary between logic and chaos. You might expect that the speed of light would vary depending on how fast you're moving. After all, if you're running toward a wave, you meet it sooner. If you run away from it, it takes longer to catch you. But light doesn't care how fast you're going, whether you're standing still, racing through space, or free-falling into a black hole. You will always measure light moving at exactly the same speed. Always. This seems impossible. It feels like a trick. But it's not a mistake. It's a fundamental property of how the universe protects causality. In 1905, Einstein didn't just propose that light was fast. He proposed that its speed is constant. No matter who's measuring it, no matter how fast they're moving, to preserve that constancy, the universe makes a trade. If light won't bend its speed, then time must bend instead. So does space. So does your very sense of simultaneity. The faster you move, the more your time slows down relative to someone at rest. Your clock ticks slower, your heart beats more slowly, your thoughts stretch. And it's not an illusion, it's not a mechanical effect. It's not because your watch is malfunctioning, it's because time itself is flowing differently for you. At the same time, your length contracts in the direction of travel. To someone watching from the outside, you appear thinner, shorter, compressed by your own motion. All of this happens to preserve one sacred truth. No matter what, light always moves at the same speed in a vacuum. It's not the speed that changes, it's everything else. And here's where it gets stranger. This isn't just about light, it's about information. The universe ensures that no signal, no cause, no particle carrying energy or data can ever outrun that boundary. Why? Because if anything could break that rule, then one observer's before could be another's after. You could send a message into your own past, and physics would unravel. The universe would become unpredictable, incoherent. Not because objects are chaotic, but because logic would cease to have a single direction. To avoid that collapse, reality chooses to bend rather than break. It curves time. It compresses space. It twists your understanding of when and where things happen. And it does all of this so that light speed stays untouched. Because light speed isn't about light, it's about structure. It's about order. It's about what comes next and what can't come before. So when you ask why nothing can go faster than light, the real answer is because the universe values causality more than it values speed. And it will bend everything else to protect that one rule. We like to think of space as a volume, an open area where things can move. And we like to think of time as a line always flowing forward. But in reality, space and time are not separate. They are woven together into a single structure, space-time. And within that structure, there is a kind of geometry. Not the kind you learn in school with triangles and arcs. It's a deeper kind, one that shapes the rules of cause and effect. At every point in space-time, there is a limit, a boundary, a region of influence. Physicists call it a light cone. Imagine standing in space right now. Draw a cone outward from your feet, expanding in every direction. Everything that can be affected by your actions, everything your light, your signals, your reach could ever touch, exists inside that cone. Nothing outside it can be changed by you, no matter how hard you try. And in the opposite direction, draw another cone back into the past. That's where all the things that could have influenced you came from. Everything outside that cone, irrelevant, unreachable, too far away, because even light, racing for billions of years, hasn't had enough time to reach you. These cones define the very idea of causality. They tell us who can talk to who, what can affect what, which events are linked, and which are permanently disconnected. It doesn't matter how clever you are. It doesn't matter how powerful your tools become. You cannot send a message to someone outside your future light cone. You cannot receive a warning from someone outside your past light cone. The universe has firewalls, not of code, but of geometry. This isn't just theory. It's how every simulation, every calculation, every model of the cosmos works. Black holes respect it. Particle accelerators depend on it. The early universe evolved according to it. Information travels through space-time along paths called world-line trails that trace where a particle goes moment by moment. And those lines cannot tilt beyond the angle set by the speed of light. Try to break the rule and the line stops being physical, becomes imaginary, nonsensical, outside the boundaries of reality itself. This is how the speed of light becomes a framework, not just a feature. It isn't a setting, it's a shape. It defines the edges of what is knowable, what is doable, what is even conceivable. And while that might feel limiting, it also gives us clarity, because without those limits, nothing could be trusted. Causality could fracture, consciousness could loop. the future could interfere with the past. But the universe prevents that, not with force, but with form. It writes its law into the shape of space-time. It uses geometry to define possibility. It lets us navigate reality not as wanderers in a void, but as beings tethered to cause, effect, and meaning. The speed of light is the angle of that tether. It is the slope of influence. In every interaction, every signal, every story unfolds inside its cone. There's a quiet trick the universe plays. It convinces us that events are happening now all around us. It's the moon hanging still in the sky, the stars holding their pose. The people we talk to, reply to, look at right there in the moment. But they aren't. Not exactly. There is no such thing as instant. Everything we see is delayed. Even light. So fast we call it immediate takes time. From the moon, 1.3 seconds. From the sun, 8.5 minutes. From the nearest star system, over 4 years. And from the edge of the observable universe, over 13 billion years. Which means when you look into the night sky, you're looking into a mosaic of ancient messages. Some from hours ago, some from before Earth formed. You don't see the universe as it is. You see it as it was, from billions of different moments, stitched together by photons just now arriving. And it's not just distant stars. Even on Earth, light takes time. A video call, a laser rangefinder, a mirror. There is always a delay measured in microseconds, but real. This may sound trivial, but it's not. It means that our sense of simultaneity, the idea that two things can happen at the same time, is not universal. It's local, tied to how long light takes to carry a signal. In Einstein's theory of relativity, this becomes even stranger. Observers moving at different speeds disagree about what is simultaneous. One person might see two events happen together. Another moving past might see them unfold one after the other. And both are right, because simultaneity is not absolute. It's not a cosmic truth. It's a matter of perspective, shaped by motion and light. This is the heart of the illusion. We believe in a universal present, but the universe doesn't offer one. What it gives us instead is a network of local nows, each defined by the arrival of information. When you see something happen, you are not witnessing its presence. You are receiving its past. You are always living in the aftermath of something else. And yet, this delay gives time its direction. If all signals were truly instant, the past and present would blur. You could change something before you observed it. Causality would unthread itself. But because light is finite, events can only influence others after a delay. And that delay sets a rhythm. It gives the future time to unfold, gives memory time to form, gives awareness a structure it can trust. The illusion of instant is necessary for experience. The limit of light speed makes that illusion possible. So the next time you look at the stars, or even at someone standing across the room, remember? You are seeing echoes. You're receiving history. And that's not a flaw. It's the only way the universe can make sense.